How are you? So in this topic, we would be discussing about the application of Newton's law. So basically, there would be similar type of questions that we would be discussing today. So first type of question would be like there will be a slant wedge over there, and some object would be on it, and the theta would be given to you. In these types of questions, see, the mg will be downwards. See, mg, do not confuse with the contact. Mg is the gravitational field force, which is always downwards. As in the projectile motion also, it was moving like this, but gravity will be always downwards. So here also it might be like this, like this. Whenever there is some object, the gravity would be always downwards. Similarly, the gravity would be downwards, but there would be contact force. So contact force will be always perpendicular to the surface. So if the surface is this will be the perpendicular. So this will be the normal. So in this case also, this will be the normal. Along with that, we would be requiring to resolve the forces. To resolve the forces, first of all, make a plane like this. So now it's a plane. Basically, in earlier cases, if we say that this is a plane, so in that the plane itself is similar as the plane the object sitting on. But now we have tilted the plane, so we have to tilt our axis also. For these axes, now we need new mg values. So new mg values means there will be one force this and another force this. These forces we would be requiring. So now see, in this triangle, so this is theta, this is 90, so this is 90 minus theta. So now this will be theta, because this is 90 minus theta and this whole is 90, so this will be theta. So if this will be theta, it will be mg cos theta and this will be mg sin theta. So this diagram is very important, and you can rub everything else. Just remember this diagram. You should never make any mistake over this, like mg will be cos theta downward, mg sin theta over there. So if this object now moves, if they say it moves in this direction, so you would go like accordingly, and if in this direction, then it depends, because there will be some forces over there. So if it is moving in this direction, so the net force, that is the F, equals to ma. So F net you would be using. F net will be equals to mass into acceleration. So force, suppose this is moving in this direction, so F net will be F minus mg sin theta. So this will be F net equals to mass of the body and acceleration of the body. So you will get the right acceleration, that at what acceleration this object is moving there. And if we say that this object is moving downward, there is no force over there, then we will say that mg, like this is another case for this case, and if it is downwards, then it will be mg sin theta equals to ma. So obviously g sin theta will be acceleration. So this is all the calculation part, but you should focus on this diagram. This diagram is very important. Mg cos theta downwards, mg sin theta over there. So this is the first type of questions. In this type of question, there could be frictional force also. So frictional force, if it is moving there, frictional force will be over here. If it is moving there, then the frictional force will be. Frictional force will be always opposite to motion. So you have to take care of it. We will have another videos on friction only, so do not panic for that. In this video we are only going to see all the Newton's laws applications. So now the second example is also very important. In the second, there could be some questions like this. So there could be like forces. The forces that are getting applied over there. This is the object 1, this is 2, and this is 3. So this is now. So this is mass 1, mass 2, mass 3. So here, along with the Newton's second law, third law will be also used. So when we will have the force, we will say that this is the force, main force, and there will be a force on 1 by 2. And for the second object, there will be a counter force on 2 by 1, and over here there will be force on 2 by 3, and over here there will be a force on 3 by 2. So these forces will be equal. Why they will be equal? Because Newton's third law has action and reactions are equal and opposite. So we would be using all the situation like this. So now F net is this. If we will take the whole of the net, this mass we can take total mass, and this will be the total acceleration at. So we will calculate at, that is the F upon capital M. I am writing it, okay? So you can write that capital M is equals to the total mass, that is m1 plus m2 plus m3. So once you have the acceleration, so this object will be also moving with same. So now you can say that F32 will be equals to ma, and m will be m3. So now this at will be same, so into force upon total mass. So this is how you have to solve these types of questions. So this is the first, this is the second. In the third, see, in the third example, these contact forces just change with the rope. So that doesn't make any much difference. It will be just T. So tension will be there. So if you will do it, it would be very similar to it. So we are not doing here. So this is a third. So fourth one is also very important. That is equilibrium of forces. Equilibrium of forces means, like, if there is string here and then string here and then there is a mass, so all the forces are now in equilibrium. This point is static. So if this point is static, we have to use the components of the forces. So this will be like alpha, this will be beta, this will be F1, this will be F2, or T. We can write it here. T would be the better force because it's a tension. So tension 1, tension 2, and downwards it would be mg. So you have to resolve these forces, and when you will resolve it, so this will be like this. So it will be T1 cos alpha, and it will be T2 cos beta. So there will be equation T1 cos alpha plus T2 cos beta equals to mg, and this will be equal here. So T1 sin alpha will be equals to T2 sin beta. So these two equations will be used, and there would be one more equation there, that is the Lami's equation. If you know, that is the rule of sine. This formula will be very handy to you. Okay, F1, F2, F3. So this is like alpha, beta, gamma. So you can write like this, that F1 by sine alpha, the opposite angle, this one, equals to the f2 upon sine beta equals to f3 by sine gamma. So this formula is also very handy and very useful in this method. And in this only there is one more figure which is like this. It is very similar, just this beta has become 90 degree. So there can be different diagrams depending upon the question. So you can use all these methods for that. So our topic has been completed with the application part. We are left with the lift questions and we will just do a short video for that also. Thank you for being here. If you have some doubts, just put into the comment section. Thank you.